Hello, this is the first FRQ of the Unit 11 project, and let's get right into it. So we have four identical light bulbs, A, B, C, and D, and since they're identical, that means their resistances are also identical. And then we also know this is our relevant equation. V squared over R. And we know that our R's are constant, and we also know brightness is a result of power. So the more power it has, the brighter it is. And then when it's in series, our current will be constant, and then when it's in parallel, our voltage will be constant, and our R will always be constant. So that's how we can tell what's going to be brighter than what. Okay, so now that we have that nice background, let's get into it. So which of these circuit diagrams below correctly represents the configuration of the bulbs? Well, that's going to be figure 1 based on this chart, because this chart shows B and D, and these are in parallel, and they're in series with C, and this branch is in parallel with A. And that's what makes the most sense based on this data, because when bulb A is removed, the brightness of bulb B and D are going to stay the same. And then your brightness of bulb C will be greater, and then bulb A will go to nothing. And then you also look, so it's going to travel out the positive side. When C is removed, everything except bulb A goes to 0. So that means bulb A is in parallel with these. And then you can also look when B is removed, then D and C are going to become equal, because then it would just be C in series with D. And your A will stay at 250. So everything in here points to figure 1 being correct. And we know it's not figure 3 because when you remove bulb D, if it was figure 3, then B should go to nothing, but it doesn't. So we're confident that it's figure 1. Figure 1. And even though I just explained it, since it doesn't say explain, we don't have to write it. Just say figure 1. Explain how the data provides evidence for the location of bulb A. Okay, well, it's pretty simple, and we kind of just explained that. So let's look at when bulb A is removed. When bulb A is removed, the brightness of B, C, and D are unchanged compared to when all bulbs are connected. So that means A must be in parallel with the 3 other bulbs. So A must be in its own parallel branch by itself. So, explain how the data provides evidence for the location of bulb B. Well, this is similar. When you remove bulb B, your brightness of bulb B will go to 0, of course. And when you remove bulb B, right, C and D will both become dimmer, but will not go out. And bulb A's brightness remains unchanged. So this shows that B is in series with C and D, but not in series with A. Yes. When bulb B is removed, our brightness of bulb A will remain unchanged. And then your brightness of C and D will both decrease because B was in parallel with D, so you remove B, then C and D become in parallel with each other, and the brightness of both will decrease. Okay. Now, explain how the data provides evidence for the location of bulb C in the circuit identified in part A. Okay, so we can look when only C is removed. When only C is removed, our A is going to remain the same. Our A should always remain the same because it's in parallel branch by itself. And C and D will both go to zero brightness when B, C, and D will all go to zero brightness when C is removed, because it's like this, and B and D are in series with C, so they're not going to get anything if C is removed. So they should all go to zero. And now, explain how the data provides evidence for the location of bulb D in the circuit identified in part A. Well, when you remove bulb D, when you remove bulb D, that'll go to zero, and then that should decrease the brightness of B and C. So when you removing bulb D and removing bulb B are going to have pretty much identical effects, except when you remove bulb B, it goes to zero, and D, it goes to zero. But this shows that B and D are in parallel with each other and in series with C, because these are pretty much the same thing happens. So you remove bulb D, then bulb C and B become in series with each other, and they're both going to become dimmer, but not out. So that's how you explain B. And then it also reaffirms that we got figure 1 correct, because the similarity between what happens when you remove bulb B and what happens when you remove bulb D shows B and D must be in parallel with each other and in series with C. And, okay, so now bulb B is removed at time t equals 0. At time tc, an uncharged capacitor is connected to an empty socket. Describe how the brightness of bulb C changes from t equals 0 until the circuit reaches a steady state after tc. Okay, so a steady state, when it reaches a steady state, that means the capacitor can't take anymore. So for 0, okay, bulb B is removed at time equals 0. Okay, bulb B is removed at time equals 0. So that's going to leave a gap in the series branch. At time tc, okay, so you're going to replace bulb B with an uncharged capacitor. Okay. So in the time leading up to steady state, with B's socket empty, this BCD branch is open, and current won't flow through. So C's brightness would be 0. And then just after the capacitor is connected at TC, the uncharged capacitor will behave like a wire. Right, okay. So it's going to be 0. So I'll write it like this. 0 less than TC. That's going to be C brightness 0. And then immediately after TC, so T greater than TC, but it's immediately after. C, the uncharged capacitor will behave like a wire, so it would suddenly surge, and then C would jump to C brightness to max. Okay. And then for a long time after TC, as the capacitor is charged, it's going to start acting like a roadblock and it can't take any more charge, and that's what steady state is. And then current in that branch would decrease continuously, and then it would decrease smoothly. Back to 0. 0, and then in the final steady state, it would be 0. It would have a brightness of 0. So these two would be the same. And that's the first FRQ. We have 9 more to do. So thank you.